Welcome everybody. Today's lesson is all about radicals. And I'm not talking like far out, man. I'm talking about the symbol. Often we refer to this symbol, the radical symbol, as the square root symbol. We know from our time studying rational exponents that the square root of x can also be written as x to the 1/2 power. We'll discover later in this lesson that all radicals, whether it be the cubed root or the fourth root, can be written as a rational exponent. But our first application today is called the geometric mean. Now, you're used to hearing about the arithmetic mean, where I add up all of the numbers in the set and then divide by the number of numbers in that set. The geometric mean is just a little bit of a twist on that. We are going to take all of the numbers in the set and multiply them together, and then take the root of the number of objects in the set. So, for example, in question number 1, we can see that I've got 8 numbers in the set. I'm going to multiply them all together. So I've got 2 times 54 times 145 times 38 times 597 times 1152 times 344 times 87. Now, I'm simply going to take all of those to the 8th root, because that's the number of numbers in the set, and I get approximately 103.
That was easy.
Yeah, now you try. After you've done the on your own problem, you should have seen that when you multiply all of the numbers in the set and take it to the 8th root, you should get approximately 1,656. The geometric mean is often used when the numbers are widely spread apart. This helps get rid of outliers and gets a true measure of the center of a data set. Alright, let's spend some more time looking at radical notation. As mentioned above, I can write the square root of x as x to the 1/2 power. I could also write the fourth root of x as x to the 1/4. Now, what if I've got x raised to a power? What if I have the square root of x to the 3rd power? Well, when thinking about our rational exponents, remember that the exponent stays as the numerator, and then the root is the denominator. So this would be x to the 3/2. We'll use that as we go through the examples. Check out example number 2. I'm going to find the different roots, and we're going to try to not use a calculator here. The square root of 64 we know is 8. The cubed root of 64 is 4. The 6th root of 64 is 2. And how about this? I've got 64 to the 10th power to the 10th root, which is really 64 to the 1st power, which again is essentially 64. If you need help remembering your roots, it can be helpful to look at your power sheet. Alright, let's look at rewriting 10 to the square root, square rooted, square rooted, square rooted. Isn't this really 10 to the 1/2 raised to the 1/2 power, raised to the 1/2 power again, and finally one last time being raised to the 1/2 power. We know from our power rules that when a power is raised to a power, we multiply the exponents. So this becomes 10 to the 1/16. Alright, you try. Let's try to write some of these radical expressions without the radical symbol and only rational exponents. Hopefully you were able to come up with some of these answers. Number 1 should be w to the 1/9. Number 2, when I simplify, and I'll go through a couple steps here, w plus 5 to the 1/2 power, and that is to the 1/3 power, should simplify to w plus 5 to the 1/6. Remembering to multiply the exponents. 3 should be c to the 1/4. 4 should be a to the 1/6. 5, I've got 3 to the 1/2 w to the 2/2, which is really equal to 3 to the 1/2 w. Number 16, the 4th root of 16 is 2. And now check this out. I've got w, the 2nd power to the 4th root. This exponent can be reduced. So I've got 2w to the 1/2. Hopefully you're catching on. Number 7, the 5th root of 32 is 2. C to the 2/5. And then our last, we're going to go ahead and get rid of the radical symbol first, and then we'll start to reduce some of the exponents. This should be 64 C to the 1200 all to the 1/12 power. Turns out I get c to the 100 times the square root of 2. All that comes from simplifying my radical symbols and then taking the 12th root of both terms. Let's take a look at the back to practice more with radicals. Okay, on the top of the page we notice that we can multiply radicals together as long as they're with the same root. So you'll know that when I have the square root of 10 times the square root of 5, that can be the square root of 50. I can also break that down as the square root of 25 times the square root of 2, which becomes 5 root 2. So it's possible to manipulate the radical symbols as long as we're talking about the same root. So for example number 1, they are both the 3rd root, so I can multiply underneath the radical symbol and I get the 3rd root of 1,000, which is equal to 10. For example number 2, I've got both 4th roots, so I can multiply underneath the radical symbol and I get the 4th root of 5 times 125, 625, x to the 4th. This now equals 625 to the 1/4, and then x, the 4th power, the 4th root. When this is simplified, I get 5x. Now you try. Try a couple of the on your own problems and then check your answer. Alright, when multiplying underneath the radical, you'll see that we get the 3rd root of 8,000. The 3rd root of 8,000 is 20. Alright, for number 2, again, since we have the 5th root for both of the radicals, I can multiply underneath and I get 32 x to the 10th power, and that is all to the fifth root, I can rewrite that with rational exponents and see that I have 32 to the 1/5 x to the 10th to the fifth root, which is equal to 2x, and I simplify my exponent, squared. Very nice. Let's get some more complex examples. For example number 3, I'm going to take the third root of each term underneath the radical. So I'm going to rewrite it as 64 to the 1/3 r to the 6th third root s to the 15th the third root. You can see I'm essentially dividing every exponent by 3. The third root of 64 is 4. I simplify my exponents, so it's r squared s to the 5th. And again, when I'm taking the third root, I'm essentially dividing every exponent by 3. Okay, example number 4. It asks us to write the radical with a smaller power underneath the radical symbol. Now, this is going to require us to break down the terms underneath the radical into things I can take the third root of. So, the number 120 must be broken down into two numbers, one of which I can take the third root of. It turns out that 8 and 15 are factors of 120. So, watch how I break this down. I'm going to do the third root of 8 times 15 times x to the third times x. Now I broke up the x to the product of two terms because I want to be able to take the cubed root of one of them evenly. So here goes nothing. When I take the cubed root of 8, I get 2. When I take the cubed root of 15, I can't take that evenly, so it stays underneath the radical. When I take the cubed root of x cubed, I get x. And when I take the cubed root of just x, I can't do it, so it has to stay underneath the radical. So my final answer is 2x times the cubed root of 15x. It doesn't look simplified, but that's my final answer. Alright, now it's your turn. Try 3 and 4, and then check your answer. Okay, you should have found that I take the cube root of 125, that's 5. I divide the exponent by 3, so that's a to the 4th. Divide the exponent by 3, and that's b to the 9th. So 5a to the 4th, b to the 9th. Okay, now to the more complicated one. I've got to rewrite it with a smaller power underneath the radical. So I need to break it down into terms that I'm allowed to take the fifth root of. So let's break this down into the fifth root of 32 times 3 times y to the 10th times y. And again, I'm choosing 32 times 3 because I can take the fifth root of 32, and y to the 10th because I can take the fifth root of y to the 10th. So my final answer is 2y squared times the fifth root of 3y. The things I'm not allowed to take the square root of are stuck underneath the radical, and everybody else is free to come out. Well, I hope you enjoyed your lesson about radicals. We'll talk tomorrow in class.